Hello and welcome to Dialog TVS, the show where we bring on industry players and prominent leaders to talk about the latest trends and the current topics and the hot issues that are going on in the world right now. As usual, I'm your host, Razi Ahmad.
And of course, with me, Shalshmato. And of course, here today, we are very fortunate enough, Ratzi, to welcome back another of our guests previously in our previous episode. Now, introducing and also to welcome not one, but three of them in the studio today. Welcoming back the CEO of Sarawak Microelectronics Design, SMD, Mr. Sherman Jamil.
Hello,
Welcome
Shara,
back.
Razi.
Round
Thank
two,
you.
yeah?
Round two. Thank you for fulfilling your promise to our viewers, of course.
Thank you for having me round two.
An honor, always. And also introducing the CEO of a Big Innovation Center, Professor Brigitte Anderson. Welcome to our humble studio in Kuching.
Thank you.
All right. Thank you so much for being here with us today. And of course, a Director of Sales of Riverback Limited, Mr. Kevin Hudson. Welcome.
Thank you. Thank you very much.
All right, and also a very big thanks of everyone to spend the time and of course to embark on a very interesting and yet hot topic today.
So it's an honor to have all three of you joining us here today for another session of Dialog TVS. Professor Brigitte Anderson, would you mind sharing a little bit about yourself to the audience out there?
Yeah, okay. So my name is Brigitte Anderson, and as I just said, I'm the CEO of Big Innovation Center, and we are a London-based think tank and technology advisory body. And we are also the Secretariat for UK Parliament on bringing evidence into policy and legislation around artificial intelligence. I'm also a professor at the University of London, although the Big Innovation Center is my full-time job. And I'm speaking here in my personal capacity.
I see. Thank you so much for having that brief introduction of yourself, Professor Brigitte, and also we'll be having more definitely, and I'm pretty sure the viewers out there are very excited to know what's next for them, especially in the field of AI and also policy making. And also to Mr. Kevin Hudson, would you also mind to have a brief introduction to our viewers, Sarawakians, nationwide and also statewide?
Yeah, sure. So as you mentioned, I'm Sales Director for Riverbeck UK Limited. I've had like 39 years of experience in the semiconductor industry, working in UK, US, across Europe as well, some of Germany and so forth, and even Sarawak 20 years ago at First Silicon. I don't know if anybody remembers that, but it's now XFAB. But
So you bring a wealth of knowledge to our discussion, our panel.
I hope so.
Yeah. So, Mr. Sherman Jamil, to our audience who might have missed last time's episodes, maybe you could introduce yourself.
Yes,
once again.
my name is Shariman Jamil. I'm the CEO of SMD Semiconductor. We are a Sarawak-based company focusing on designing integrated circuits or chips, but not potato chips, as what mentioned in the previous episode.
Remember, Betsy?
We are fully owned by the Sarawak government under the Sarawak Research and Development Councils, and we reports to the Ministry of Education, Innovation and Talent Development Sarawak. Yes.
So the last time we spoke in our previous Dialog TVS Plus episode, Mr. Shariman, it was about green chips, as you said, and how important green chips are for the future, for a sustainable and green future, especially here in Sarawak, as green chips are more powerful, they're more efficient and more sustainable in terms of production and environmental impact. And you talked about the strides that Sarawak is taking towards achieving that future.
Yes.
This time around, though, since we have a esteemed panel of guests here, we would like to talk about the rise of artificial intelligence and how artificial intelligence or AI necessitates the production of green chips. So AI is the talk of the town nowadays. Everybody is talking about AI in the world right now.
Yeah.
It's made its way into the daily lives of almost everyone, and everybody uses it to help doing their homework and image generation. It has uses in businesses, in economics, in science, in military, and so on. So, but for many people, how AI works what AI actually is not really clear. It remains a mystery to them. So, Professor Brigitta, I would like to ask you, what is AI actually? Is it like a real thinking machine? Is it like a real computer that can think for itself? Is it an algorithm? Is it a sort of code that pulls from the collective knowledge of humankind from the internet and parses it into very easy to use applications? So what is AI in a nutshell?
It's all of that. It's everything what you mentioned here.
Really?
It's because AI is, well, first of all, we first knew it as machine learning. And these are intelligent machines that can kind of learn from themselves. That means that machines are using data and they become training data. So that means that as the machine is taking data and is operating, it's learning to do more precision in the way in which it operates. So it learns from the training data. And that was kind of the deep learning element. That was how it came out. That was really popular for maybe 7, 8 years ago, or maybe even 10 years ago. But then AI has taken on a completely revolution, as you mentioned. So today we talk about many different types of AI. We have autonomous decision making. And that means that AI is actually able to make decisions for you better than you could do yourself. You can make your own financial decisions, but maybe the AI can do it better for you, or you can make your own health decisions, but maybe the AI can do it better, or if you're a doctor at a hospital, the AI can do it better. Of course, we also have robotics and automation. That's when the AI takes in all the algorithms and calculate what is the most optimal way to paint that car or to do that mobile phone in the factory, etc. Yeah. Right now, what we hear a lot about is chatbots. When you shop online, you're speaking with your chatbot. Yeah. So it's actually becoming a service element. And AI is also applied in facial recognition. So that means that street cameras can recognize you. When you walk into SMD Semiconductor, the door opens if you have the face that's installed in the system. But if you don't have it, the doors won't open. And I could kind of go on about this. Drones, this is where AI becomes more like robots. And therefore, they're physical, where you have those in the algorithms that's more intangible. So we talk about the difference between physical AI in kind of set up in drones and then tangibles. And we talk also about AI producing tasks versus general AI intelligence. That's when AI becomes almost human. So there's a huge area, and that I just talked about a corner here. There are many fields. So AI has come to control completely our lives and the way we are conducting homework, as you mentioned, or the way we go to work, and the way we live in our houses, and the way we use transport. So it's, but it can only do that if it's really have some chips inside. That's actually where all the information is flowing.
Yeah.
So I think what Prof. Brigitte trying to say is from just a device point of view, I think artificial intelligence is the science of making a machines or any computer systems that can think like a human being, that do things like human being. And Brigitte just elaborated a few of the examples just now. Yeah.
Yeah, and also, but the scary part of course, when it becomes more clever than a human being is, and then it cannot explain itself. So we talk about explainable AI and non-explainable AI, and now the big conversations, of course, in policy is to what extent AI should be able to explain itself, or what extent that if we get the solution we want to, does it need to explain everything? So these are one of the regulatory aspects. Also, when AI is the way in which it works on social media, we have had the big discussions more recently on how it works with the social media channels like Facebook, Instagram, and all this. It's been all on the news. We all watched the last couple of days. Right. The big hearing at Capitol Hill in America is to what extent AI can control how the algorithms control the way we interact with mobile phones. So this is, and of course also in automated decision making, who is having the responsibility when it goes wrong? Is it the chip producer? Is it the designer? Is it the manufacturer? Is it the people who actually using it? Who has the responsibility? Well, that's not clear either yet.
So there's a whole moral quandaries surrounding moral and ethical quandaries
It's
surrounding
the attitude
AI
that is very important, which I mentioned in the first episode, that it's part of the whole development of technology for the betterment of human.
Yeah, exactly. And the technology develops very, very fast now.
That's true.
And of course, neither business models or policy can follow, but the adoption happens very, very fast. And there's this big discussion to what extent the adoption should be held back. And that's, of course, a major thing. We heard from Elon Musk here more recently, and they can now have the chip that goes into the brains and interfere directly in the brain. And of course, there are lots of things that could be problematic. You know, when we can kind of download people's brains, people's memories, that will happen. Some people claim they can do it already now.
That's right.
But what we really need to think of is how AI now is controlling our everyday, but we have to also make sure that we as human beings need to stay in control. We need to create the rules and the norms and the standards and regulations. So we need to think of how we want to live and how we want the AI interact with AI. So human-machine fusion becomes a big thing now.
That's true, because with the information obtained, like you mentioned also earlier on algorithms, for example, when we search on something on Facebook or on Marketplace or TikTok perhaps, it can sense the pattern of algorithms that we have from there, and it can pop up we can realize, I think for the viewers also at home, I think they realize once you search something, it will pop up. So I think there's a certain privacy act that has to be created into more awareness among users and educated as well. And I think this is a great area, Professor Brigitte. I mean, if we to have you here as one of the big names in policy making as well, perhaps Malaysia should also look into the matter on incorporating AI and also the Protection Act that we're going to have also as well, and also to for those as AI is making a significant impact, right, Mr. Scheumann, environmentally and socially, as we can see, and as the world embarks on this exploration, coming from us, I think it's crucial to recognize the impact of AI in our daily lives, and namely, like what Professor Brigitte has mentioned, improved healthcare, education, and also in decision making and business decisions making as well, and education. Perhaps from your opinion, before we go on to the next segment, Mr. Scheumann, could you also share some insights on the applications of AI that perhaps we can encounter in our daily routines?
But I have to stop you there, Mr. Sherman. Sorry, Cheryl. We have to go for a quick break.
Sure.
We'll leave that really question after the break. Yes.
Yeah, that was really passionate start to the episode, but we'll be right back.
And we are back once more in Dialog TVS, and this time to, of course, continue the heat of our first segment earlier, yeah, Bretzi? And thank you so much also as well for coordinating the entire conversation earlier. And also thank you to Professor Brigitte, Mr. Scheumann, and Mr. Kevin also for still being here with us today. Now, earlier we were mentioning to our what our viewers know is a little bit on, in a nutshell, what AI, artificial intelligence, is. And also previously, Mr. Scheumann, I asked that AI is indeed making a significant impact now environmentally and also socially in business decision makings, also in the first, as covered as in the first segment. And as the world embarks on this innovation exploration, it's crucial to recognize this impact in our daily lives. So perhaps you could also share, in your opinion, and some insights into the applications of AI that is incorporated in our daily routines.
Well, I can give you one example, which is what we have seen in our daily life. We talk about this generative AI, ChatGPT. You would be surprised now that a lot of students I'm not encouraging this, but this is what's happening, that starts to ask questions on ChatGPT on some of their homeworks. So I think teacher, please be aware of this. And this is quite the in thing at the moment. And this is just one good example how AI can influence, dictate our lifestyle.
I think there are now programs to detect, like for teachers, that can detect where chat GPT has been used.
I see.
Yeah.
Right.
So you counter AI with AI.
Yeah. Yeah.
So you counter AI with AI.
Yeah.
Right? Well, if I would like to know what is the system that can detect, and I mean, is this specifically for educators, or that can detect whether the student or the person is using ChatGPT?
It is
Yes.
for educators. Yes.
Yes.
That's in all kind of marking systems,
Yes.
even at the University of IM.
Yes.
So what we've gleaned so far is that AI, artificial intelligence, is very powerful, and I assume it requires a very powerful, brain behind AI. It needs a very powerful microchip, the brain, the CPU behind AI. So Sarawak Microelectronics Design, SMD, that you are head of, is pursuing green chips. In efforts to empower this AI-powered future. So I would like to point this question to Mr. Hudson. For those out there not very deeply immersed in the semiconductor or the AI landscape, what is the significance of green chips when it comes to powering AI? What is the difference between the conventional silicon technologies that are being used by companies like NVIDIA, and how does green chips is different? How is it different from the conventional silicon
That's a very
chips?
good question.
Yeah.
And it's very difficult to answer.
Maybe I can start to give some inputs to that question. Sure. Since you asked a very pertinent questions about what's the difference between AI chips and non-AI chips, and what its green agenda got to do with these chips.
All right.
So let me try to answer this in a very technical. I hope I can make it in a very easy to understand,
Easy to digest. Yeah.
easy to digest. We've up to this point we've known that AI is about processing the informations, and the brain of AI is actually the chips. Microchips is the center of AI evolutions. Without microchips, there is no such thing as AI, because you cannot process the information. Now, the conventional chips in the past, they also process information, but they only process that information sequentially. So even though the information is processed fast, but it is still in a manner that it is processed sequentially, the information. Now, AI chips, because there are so much information that needs to be processed and compute, so AI chips works in a manner that they have a few multiple processors functioning at the same time. So you are processing the information in parallel. So in a much more faster mode, because the future chips will require a lot of data, graphics information that needs to be processed. So by looking at that point alone, it is very obvious that the AI chips really needs a lot of power to operate, because you need to process a lot of information.
That's true.
Imagine that if you are holding your mobile phone and you are talking to your friends for 2 hours, and you will feel the heat coming out from the device, simply because the processor works very hard, because you are now having a live streaming information. So it's a similar concept. When you are processing a lot of information, then it consumes a lot of energy just to process those information. So that's the basic of AI chips about. Now, chip designer has to come up with a strategy to embed a sustainability a green agenda into the design of the future AI chips, looking at to design for optimum power efficiencies, because AI chip is going to burn a lot of power. So it is the responsibility of the chip designer to make sure that the chips is power efficient. So this is one of the example key critical area where chips play a very important role in artificial intelligence.
That's right, Mr. Shariman. Also, as well, when you mention also, this is also towards the sustainability and the production of the green chips itself. There is a difference between the conventional ones and the non-conventional ones, and also relating to building on Mr. Shariman's response. My question is towards Mr. Kevin. I mean, what are your thoughts on the steps taken by SMD, as mentioned by Mr. Shariman, described by him on the green chips, in pioneering a sustainability strategy this time for microchips? I mean, how does it align, when we talk about sustainability, how does it align with current global efforts that we're having? What makes it noteworthy when you compare it to similar initiatives?
Yeah, I mean, SMD is really put their foot in the door when it comes to sustainability. They're really focused on their design methodologies, and I think working with partners to encompass that.
I see. That's right.
Right.
Yeah, and I can just add also that I think that this area of sustainability is very important right now, because as the chairman mentioned, that the current technological revolution is burning up a lot of energy. I know it looks very clean, and I know that everything around the chips is already highlighted as in a very clean, white, shiny way. But chips actually, not chips, but the microelectronic revolution and AI revolution is not a clean technology, because it burns so much energy, and everybody is using more and more processing power. So the whole sustainability revolution around this, that's touched by United Nations, by European Union, by global agendas, is to find a way in which we can create the current revolution green and sustainable. And that we're looking at both the environmental factors, of course, that we need to keep the environment, but we're also looking at the social and health and safety factors around the applications of these. And this is both in relationship to heat and that can be related to it, but it can also be health and safety in relationship to the way in which it's applied, the chips, and the microelectronics. And then we have the economic dimension in terms of increasing productivity and efficiency. And then we also can go to the recycling aspect. To what extent are we creating integrated circuits that's just thrown away and sitting on the garbage fields, as it has been for like 30 years? Or to what extent we are creating integrated circuits that can be put apart and go back into recycling? So that, because what we have so far, the competition in the microelectronic revolution has been so much about first mover. So these developers have not been thinking about sustainability aspects of it. It's all about big productivity and first movers and getting first to market, but not about actually the social, environmentally, and recycling factors. And this is what SMD is now putting into the center and saying, we want clearly to create the best solution for the user at the same time as we want to create the best environment. So by getting their chips, that's ambition, of course, that this is the green chip. That's the one that's actually helping the environment.
This is a very interesting topic, because people talk about it. People talk that we are going into a sustainability, we are sustainable, but there is no really a proper mechanisms on place, a proper legal compliance, certification, proper engagement with the government and stakeholders. This is the ecosystems that needs to be developed. And the sustainability, currently what we are doing is we embed sustainability into our business model and business plan, and also very important in our technology roadmaps.
Right. So could you provide some specifics on the the components that SMD's sustainability strategy that you are pursuing?
Yes. The way we do, because we are innovators and we position ourselves to be the leader in this area for the regions. So we are anchoring on projects that align with United Nations Sustainable Development Goals, SDG. One of the example is currently we are anchoring projects on SDG 15, which is life on land, together with Land and Survey Sarawak to develop a new GPS and sensor chips for landmarking and quantity surveying solutions for Sarawak. That's one of the example how we tackle life on land, SDG 15. Another projects that we are currently working with Big Innovation Center and Prof. Birgitta herself is looking at SDG 14, Life Underwater, where we work with Malta Enterprise to develop a GPS chips for underwater solutions. The key challenge that we're trying to address here is a GPS technology, when it comes to 5 meter below water, then that's where a lot of challenge come in because of the wave propagations and all. So you can't measure your coordinates below 5 meter underwater.
Right.
So this is something that we are trying to address with Big Innovations and also Malta Enterprise. In the recent MOU signing with Riverback, we also announced our collaborations in developing a new radio frequency chips for satellite application. This is a huge potential market for our region, particularly in Sarawak, looking at satellite communication devices on Earth as well as on the orbit, microsatellites. So I think this is another interesting projects that we collaborate under the, I think it was the SDG partnership for the...
I mean, these chips are very complex and they need a lot of experience. And unfortunately, the talent, they don't have the talent here in Sarawak or even a lot of, across a lot of Asia to work on, to develop RF radio frequency devices. So that's where kind of Riverback is kind of playing its role with our team of very experienced.
I see. And also speaking on the perspective, I mean, from Riverback as well, Riverback Limited, I mean, what are among the other contributions when we talk about where we incorporate talent development, and we do agree that perhaps there is a need of these talents to cater to the market and the soon-to-be big thing and innovation, Sarawak setting the tone in the green industry. And on the perspective of Riverback Limited as well, what contributions can your entity perhaps make in the realm of chip design specifically? I mean, any insights or projects that Riverback has been involved, and how can they align also as well with the mission of sustainable technology?
Yeah, I mean, the team back in the UK, whilst it's a small team, they have over 300 years of experience collectively doing RF design. And we've worked on projects for like the European Space Agency, so that kind of goes hand in hand. And then one of the objectives is working with SMD to try and train their staff in the nuances of RF.
I see. The new season.
So I think one of the key objectives that we are exploring is in the knowledge transfer itself. Because Riverback is very experienced RFIC chip design house. So I think this is also aligned with SDG partnerships for the goal, where we partner with a lot of international partners for the common objective, such as Big Innovations and Riverback, and we emphasize sustainability in our framework, in our partnerships, collaboration framework.
I see. And also congratulations, because recently it has been announced on the partnership that SMD has also quite recently also under MYTV, right, Mr. Sharman?
Yes.
And also circling back to the real-time effect of this technology as well. I mean, with the impact of green chips, and then now we're talking into more on the business landscape. Now, we would just like to ask, as SMD has recently announced its pioneering its sustainability strategy in microchip production, right? And also against the backdrop of global climate discussions, I mean, recently with COP28 last year held in Dubai, this sets the tone for Sarawak to foster more collaborations, with this recent announcement being one of the pioneer for this upcoming year. I mean, in the green industries, what sets SMD's approach apart to set the tone for Sarawak? I mean, being in the global arena already, and how does this strategy as well contribute to a sustainable future, this time in the business landscape? Mr. Sharman.
Thank you. As I mentioned before, a lot of people talks about sustainability, but at SMD, we make it real. So that is what the recent announcement is all about, where we will collaborate with Big Innovation Center, and we are going to develop a pioneer frameworks, a sustainability framework strategy, and also a circular economy strategy for semiconductors in Sarawak. So we are going to look at a few components and strategies. I think Professor Brigitte will touch more about these strategies, but the key objective that we are trying to achieve here is to develop a new blueprint, a framework for our local industries on how we can incorporate a green sustainability agenda in our business, in our policy, in our talent and education, so that we can harvest the maximum impact out of these strategies.
All right, thank you, Mr. Sharman. For those of you just joining us, we are in Dialog TVS with Mr. Sharman Jamil, the CEO of SMD, and Professor Brigitte Anderson, the CEO of Big Innovation Center, and also the Director of Sales of Riverbank Limited, Mr. Kevin Hudson. But we'll be right back after a short break.
All right, and welcome back to Dialog TVS here. And also, Ranzi, we've been having a lot of discussions on AI, on green chips. Again, not the potato chips this time. And of course, we have our esteemed panels who have been here with us since just now to talk about the advancement of technology, Sarawak setting the tone in the green industry. And this time itself, we'll dive deeper on the technology and also the policy making of AI also as a whole, and also with the future collaborations that we're going to have in this final segment. So for this final segment, we'd just like to have Professor Brigitte on your opinion also. Just now earlier, Mr. Sharman mentioned on the business landscape model. Now, with your extensive background in the business model innovation as well as the digital economy, which is a very complicated realm, as we all know, but I mean, in your opinion, what additional steps that both SMD and also policymakers perhaps do you believe are necessary to ensure that sustainability, there's a check and balance in line in producing this time on green chips?
Okay, thank you very much. And I think that one of the important things that Sharman mentioned previously regarding the sustainability around the green chip is that it's really going to be part of the DNA of chip design. It's not like we can develop this maximum chip that can do like we've done so far, but then afterwards we think we have to make the economy green, because of it's the way in which the chip design is working. So therefore it has to be from the designers, needs to collaborate with the global standards, with the policymakers, and they also have to collaborate with the manufacturers and even the suppliers of the minerals going into it. It cannot just be that that we have one component in a supply chain that has all the responsibility, or that the supply chain is just developing something and then And then afterwards, we need to talk about how it's polluting the environment. It has to be an integrated, holistic approach. And that is why it's very important. The collaboration is very important between designers, between policymakers, between users, between manufacturers, between everybody in the supply chain. For that, of course, everybody needs to look after their own corner. But it's still important to be leading that supply chain. And also the strategy, which I know that the SMD is taking on, is what we talk about, the holistic sustainability and the circular economy. And this is really also taking in the kind of compliance elements for like United Nations sustainability goals and for other, about 15 or so global compliance aspects of it. So it's very important that we are leading this. So we have the DNA of the chip has to itself be signaling sustainability, and then we've got the environmental factors. We talk about the energy efficiency, both in the production of the chip, but also, of course, in the design of the chip, the way it's used. We have the social aspects about the health and safety aspects of the chip itself, and we have the economic dimensions I mentioned previously. But I think that the longevity of the chips, how long time does it last? Does it last like 1 year, 10 years? Can it be reused in new ways, and can its components be taken apart for recycling and all these things? So it's very important to create this strategy that is very specific and measurable, so the outcomes can be measured, to know your role in the economic landscape, and also to know what you can do. But the same thing should be done by suppliers and users and manufacturers, etc. So I think this is very important. So policymakers, what they do now, they create all these round tables, as we had the meeting in Dubai, the COPs. That's not the only one. There are meetings around the world all the time. And this is not just places where important people meet. No, that's places where we try to make a difference and try to play part. And SMD have looked at, they want to take that very serious in chip design, because the chip is so central for all this kind of information processing. And by leading that and taking that very serious, this is playing a big part in the kind of in microelectronic revolution, and of course very important for this region as well.
Yeah. So you, Professor Brigitte, you play a very significant role in the UK when it comes to policy making surrounding these microchips or digital economy and all that. So circling back to that, Mr. Sharman Jamil, will we be seeing a similar system here in Malaysia when it comes to the technology leaders informing the policy makers in government surrounding creating policies on a green economy?
Yeah. In our recent MOU signings, which also witnessed by the British High Commissioner, Ms. Elsa Terry, part of the collaboration between this region, which is Sarawak and Malaysia, and the UK government, is to look into partnerships in semiconductor ecosystems between the two countries. So yes, definitely through the framework that we are currently developing, we are looking forward to see more engagement, more involvement from the policymakers, from the educators, and also from the public, not just the industries and innovators like us. So this is one of the key goals that we're trying to achieve through these frameworks that we are going to develop together with Big Innovation Center and the team and other partners, industry partners.
Right.
And then also the issue of certification. So really set some benchmarking on what's acceptable and what's not acceptable, and how all these different components of sustainability can be measured. Yeah. So the same thing as you have, when you buy a washing machine, all is it's certified in terms of how much energy used. Of course, that's a very simple certification. But it is almost like you need to have a barcode on with lots of different specific aspects of the sustainability agenda, and you can benchmark your chips against that. So therefore, what SMD Semiconductors is doing, they are trying to create that barcode and trying to set their standard of their chip and how that because it becomes very easy to communicate the impact on the environment, and it's also easy for buyers or users of the chips to know how does that chip compare to other chips, because the problem, of course, is we need to generate a transparency around this, so we don't have this kind of greenwashing talking about but not doing it. So I think that that this is very important to make these things transparent, and that's what we have been looking at.
I think one of the problems is that chips are developing so fast and products are developing so fast. Like if you need a new phone every year, then that's generating an issue. But then even things like cars, the semiconductor content in a car is rising expensially.
I mean, you're going to have self-driving cars very soon, I presume.
So it's a lot of aspects that
needs to be looked into, and this starts with the chip design. That's the thing that we need to communicate with everybody, that all the foundations of all these policies, strategies, technology and innovation is actually driven by the chip design. So it's very important that we embed the right strategy and attitudes to ensure that we can produce a more sustainable solutions that will bring benefits to the environment and to the mankind.
Right. So you touched on how important green chips is towards achieving that future. So can you elaborate a little bit on the function and applications of the chips that are being produced by SMD, and where will we encounter these chips in our daily lives, and how do they contribute to the broader landscape of technological advancements?
Well, one of the projects that we are currently working with our European partners is looking into the designs of automotive chips. As you know that, even in a normal petrol car, you have at least about minimum 50 chips inside every car. So if you're talking about EV and all those future transportation, you're looking at hundreds or even thousands of chips in a single EV car, for example, right? So there's a lot of new application in this automotive chip segment.
The cost of the semiconductors in a car, say today, is probably around $500 content. But if you look forward to like 2030, it's going to be more like $4,000.
$4,000.
Yes.
So it's a huge increase.
That's a huge increase.
Yes, it's a huge market. And we are also looking at development of GPS and sensor chips, as I mentioned, because it's very important for SMD to look into the application of the chips itself for Sarawak to start with, because we have so many data to capture, we have so many problems that needs to be addressed. We need the solutions to deploy solutions for our environment, for our agriculture, for our educations and stuff. So I think we are also looking into the application of the chips that we designed to go into a bit more downstreams. We are also looking at some of the SDG projects, like the one that I've mentioned with Malta, GPS and sensor for life underwater. And we are also having collaborations with Riverback now that we are co-developing a new radio frequency chips. We think that because we are quite, I would say, comfortable in the automotive segments and standards. So automotive and aerospace, the standards is quite more or less same. So for automotive standards to switch into aerospace is not something that require a big leap as compared to consumer. So we leverage on this strength to partner with prominent companies like in the UK, under this UK semiconductor collaborations umbrella.
If I could just comment on what could quite interesting maybe for users to think about here is that the chip is what we call a general purpose technology. That means it can be applied as a general purpose. It transforms every aspect of the economy, every aspect of every sector, every aspect of every product we have, and the way we receive our services at hospitals, at the doctor, at school, or at the bank. It transforms everything. And the revolutions we've had in technology historically, we've had certain technologies that have done the same thing, like mechanization, the steam engines. We have had the railways transform the whole society we live in. We've had chemistry. We've had mass production with oil as input. Yeah. And now we have to look at what is the railway of today, what's the mechanization of today, what is the assembly line of today? That's a chip. And that's what we need to understand, that it removes everything. So we talk about applications of everything. So that is a matter of course, where we start. But we need to get it right, because this is a general purpose technology, and that's going to be hugely important for every sector and for everybody, even if they cannot see it, because it's not like it is physical a chip, but it's not like the railways you can see and jump on.
Because it's too small.
But it has changed everything you hold in your hand and everything with you have these services, and that's very important. So the users needs to care a lot about it, and they need to be aware that that's where the energy goes right now.
So basically, you're saying these chips and AI will change the way we live our lives.
Completely, the way we live, the way we go to work, the way everything around us, all the products and services around us, and therefore it's just very, very important that they understand the centrality. And it's not just some kind of academic thing or something like a very specialized engineer needs to only concern about, like the one back in the office or back in the an R&D department, the specialist, and that's his job. It of course is his job, but it's integrated with everything.
Correct. So that there is a need for this integration actually, and to have this chips, there might be obstacles and hindering progress in the midst to create a more sustainable future for all. And it's more complicated than complex as it seems. It fosters not only R&D but also those on the ground, and also maybe from each and every one of our esteemed panels for today. I mean, what are the hindering progress and the impending the future of green chips, and what can, I mean, in your perspective, with this collaboration and big announcements and also the MLA that we just had, what can we see in the future of Sarawak in chips making?
Well, maybe I can start first.
Sure.
I think this part of region has the upper advantage of being one of the most attractive spots for investment when it comes to a green energy and sustainability agenda. So we have to grasp this opportunity. If not, other countries will definitely, start doing this if we don't start it first. So leaderships for us is very important in this green agenda, as what being highlighted by our Premier of Sarawak. Since Sarawak now is looking into hydrogen, green agendas and all that. So we already providing that kind of leaderships here in the regions. What's important is for the organization like us, the government organizations, to execute that policies and to come up with a 3-fit implementation strategies to make sure that all the policies and directions can be materialized in the next 5 to 10 years. So I think our role is very important to ensure that we execute the right strategies, technology solutions to make sure that we can fulfill that objective.
I think there's a lot of emphasis now on talent development.
Exactly.
Yeah.
Yes. And it's one of the main components that will be the key success factor in this strategy, the talent, to drive the talents, to make sure that we have enough talents to do this kind of missions, I would say.
Yes.
And it's also about political will and enforceability, because there's no point in we have all these meetings around the globe if it's not enforced. So, so therefore, political will across the globe is very important here. Because we know that we can always agree it sounds good in theory, but our economy is willing to do it. So I think the political will is very important, and to enforce it. And transparency is very important, as I mentioned before, that you have to be able to measure how sustainable things are. So I think this, and the users, or the whole supply chain is very important. The users need to care. You know, when they pick up a mobile phone, they need to care how much energy is burning.
Yeah.
We all don't like the mobile phone. All of a sudden, if the battery doesn't work well, it runs out, etc. But we need to understand that the chip inside is very much about the durability of the phone.
That's right.
At some point, when they shop electronics device in a mall, we want to have this mindset that I will pick the most power efficient products. Well, that's one of the small things that we need to create an awareness to the users on these types of green agenda.
I see. I mean, this is has been very interesting.
Yeah, it's been a very insightful conversation that we have
gone
today.
from artificial intelligence to green shift to sustainability, and also a bit of review on what this collaboration, as we can see, the 3 panels that we have in the studio towards a better Sarawak.
And most of all, I feel like we've learned how important AI is for the future of mankind, and how SMD's Sarawak Microelectronics Design is striving towards that future of AI by empowering it through green chips.
Yes.
And as always,
it's not without its challenges, Radzi, but I believe with the fostering the collaboration that we have, and also talks across the globe, it can create a better future, and of course the need for more talents to cater to this industry. And of course, Radzi, as usual, time flies when you're having fun. So
last time I said it was 50 minutes was not enough. Now I feel like 1 hour
still not enough.
Maybe we need another episode.
Perhaps we will need. Perhaps the audience might be waiting for the next one. In the next episodes, perhaps, right? Yes. So once again, thank you so much to Mr. Sharman Jamil, CEO of Sarawak Microelectronics Design SMD, and also CEO of Big Innovation Center, Professor Brigitte Anderson. Thank you so much for being here with us. And of course, finally, Director of Sales of Riverbank Limited, Mr. Kevin Hutz. It has been a pleasure to have this wonderful discussion and insightful topics that we have today, and we hope to look forward to more. And thank you so much for having you and us also here on Dialog TVS. And for that, we'll hope to see you soon. Signing off here with me, Shal Shamato.
And I'm Razia Ahmad. See you next time on the next episode of Dialog TVS.